Hi guys, welcome back to my channel Pirai Academy. In the series of Soliton interview question, today we are going to see about a question called number of leading zeros in binary representation. So it is categorized into the easy problem, and it is pretty much easy problem also, except the brute force approach. Okay, in this problem the brute force approach is big headache because let us see the question, then we can go why the brute force is big headache. Okay, see here, if the given input is 9, then I will be returning the answer as 28. Why? Because the leading zeros in the binary format of 9 is 28. See here, this is the binary representation of 9. Basically, binary representation will be of 32 bits. Okay, that they will be given in the question itself. Either it is 32 or 64, whatsoever, they will be given in the question itself. Okay, now we want to find what is the length of this binary digit. Okay, it is 4. For 9, the binary length will be 4. So 32 minus 4, which is equal to 28. So that's why we are getting the output as 28. Hope you understand this. So what is going to be your brute force, or what is going to be the approach that is coming directly in our mind while seeing this question first time? It is like, hey, just convert this 9 into the binary format. Okay, like 1001. Now just take the length. Now just subtract this length from 32 and return this as our output. But it is big headache. Really, I'll be telling you what is the best approach. Then you will be telling that brute force is a waste approach, or it is bit headache approach, not waste approach. It is bit headache approach. So see here, whether we want to definitely change this into the binary representation, because always remember, whenever there is a problem, then you want to find the solution for what is the exact problem. Okay, like that in this problem also, whether we want to find the binary representation of the given number or not, my answer will be no. Why? Because the simple answer is, see here, this is what 2 power 0, this is what 2 power 1, this is what 2 power 2, here 2 power 3, here 2 power 4. Okay. Now I can simply tell you that if some value is in between 2 power 3, okay, in between 2 power 3, some value, and which is equal to 2 power 2, then I can tell you that it will be of 3 digit. Can you understand this? For example, 5 is in between 8 and 4. Yes, and this 5 is of what? 3 digit. So immediately I will be knowing the binary representation length. Then I will be subtracting from 32 and I will just returning it. Can you understand this? Yes. So the core logic behind this is, we want to find the immediate next number, and we will be returning that next number's power of that 2. For example, here it is 9, right? I will be clearly stating now, what is 2 power 0? It is 1. Whether 1 is greater than 9? No. 2 is greater than 9? No. 4? No. 8? No. 16? Yes. Then what is going to be my answer? It will be 32 minus 4, which is equal to 28. Hope you understand this. It is simple. It is simple than this brute force approach, because we are just skipping one step. What is that step? The step is, we are not converting into a binary representation. Fine. Now, how we are going to implement this? Initially, my value will be 1 and power will be 0. Now I am checking whether 1 is greater than 9. No. Then I will be changing this as into 2. The value will be into 2, because see here, this is going to be my value and here it is going to be power. Okay, so it will be 2 and it will be 1, like 2 power 1, which is equal to 2, or 2 power 0, which is equal to 1, like that. Okay, now check whether 2 is greater than 9. No. So make this as 4 and make this as 2. Now 4 is greater than 9. No. Make this as 8. Make this as 3. Now 8 is greater than 9. No. Make this as 16. Make this as 4. Whether 16 is greater than 9. Yes. Then stop here. What is the binary length? It will be 4. So 32 minus 4, which is equal to 28. So 28 will be my answer. Now tell me, what is the time complexity? The time complexity will be O of log n base 2, because we are consecutively dividing or here multiplying with 2, right? Now what is the space complexity? It will be O of 1. So this is for the positive numbers. Okay, sometimes they can be also giving you the negative numbers also. For those negative numbers, always this most significant bit will be of 1. So whenever the given integer is a negative, okay, whenever the given number is negative, then I will be returning 32 as my output. Whatever the number, if it is negative, which is less than 0, then I will be returning 32. That's it. Hope you understand this. Because leading 0 means all things will be 0. But here the most significant bit will be 1. Fine. Now let us see the code so that it will be more clear, and always prefer C programming, because in Soliton they will be only asking C programming. Okay. So just to learn how to code without using inbuilt functions also. Fine. Now see here, I am just writing a function here. Okay. Inside this function, first of all, I am just checking whether the given number is less than 0. If it is so, I will be returning 32. Okay. And then here I is equal to 0 and the multiplier will be 1 initially. Fine. Now this is nothing but it is this is value and this is power. Okay. I will be power. Okay. Now if n is greater than the multiplier, then I want to just do what? I plus plus multiplier into is equal to 2, then return 32 minus 1 after completing this entire loop. Then I am just calling this function in the main function. Let me run this. Now let us see the coding path. Always prefer C programming in Soliton interviews, because they only prefer C programming. They won't accept any other programming. Okay, fine. Now initially I will be just taking a function that will be calculating how many zeros or leading zeros are there in the binary representation, and inside that the parameter will be the n, and I want to check whether this n is a negative number. If it is a negative number, however, its most significant bit will be what? Will be of 1, right? So it doesn't have any leading zeros, so it will be 32. We will be returning 32 as I explained in the drawing explanation. Okay. Now if int I is equal to 0 and multiplier is equal to 1, like in the drawing explanation I have used power, right? Instead of that power I have mentioned here as I, and instead of the value I mentioned multiplier. Okay. Now while n is greater than or equal to the multiplier, then what should I do? I will be just incrementing my I value by 1 and multiplying or exponentially I will be incrementing my multiplier by using into 2. Hope you understand this. Now when this loop gets terminated, I will be returning what? 32 minus the power, which means I. That's it. So in the main function I will be calling this respective function to calculate the number of zeros or leading zeros. Fine. So let me run this, and also you want to just make sure they will be giving you the integers. Okay, it is not we are just assigning like this. You want to get the integers from them. Okay. And also I just made an introduction video on how you can get the inputs in various formats. Just go and watch that also. I will be giving that link in the description. Fine. Now here comes the output 28. What is the binary value of 8? Its length will be 4. So 32 minus 4, it will be 28. So 28 leading zeros will be there. Fine. So this is how this entire coding looks like. And if you really like this video and subscribe to my channel, don't skip any videos in this playlist, because every video will be helpful when you are appearing for the Soliton interviews. And to know about these kinds of algorithms, just go and search in my YouTube channel, where I have made an entire bit manipulation playlist. Thank you.